Hello, this is John from caveofprogramming.com. Welcome back to C++ for Complete Beginners. And in this tutorial we're going to look at floating point variable types in C++. So again, I'm going to give you quite a lot of information in this tutorial, and you don't have to memorize it all. The important thing is just to try playing around with some floating point variables a bit, just so that it's kind of in your head. You don't really need to have all the exact details in your head all the time. So we've already seen that you can write stuff like int value equals 6, and you can output that with cout like this. Value, let's put an endler there and a semicolon, very important. So if I run that, we should get 6 appearing down here. But what if you want a decimal point in your number? You can use a type called float. So let's type float, I'll still call it value again, I suppose, equals, in fact let's call it f value, because I'm going to have a different floating point type shortly. Let's say equals 76.4 or something. Then we can output it in exactly the same way that we did with an int, but the important thing is that float can have a decimal point in it. If you're in some part of the world other than the UK or the USA, you may be used to using a comma instead of a decimal point, but as far as I know in C++, it always follows the American kind of standard of having a point here. So let's run this, and let's change this to f value, in fact, for float value, and I'll run that. And here we should be able to see 76.4. Now there are a few things to note about this. One thing is that cout, it can output numbers in one of two basic formats. One is kind of the normal notation, which we call fixed, where you write all the digits out like this, and the other is what we call scientific notation, where you have like a single digit number, point something or other, and then times the power of 10. And sometimes with big numbers, cout can decide to switch to scientific notation, and we don't want that, and I want to stop it happening here. So what I'm going to do, and you'll see how this works in a minute, is under where I put include iostream, and before using namespace standard std here, I'm going to type hash, whoops, that was the wrong key, hash include and io_man_ip, like that. That stands for input output manipulation. And now immediately after cout, I'm going to have one of these chevron things, the insertion operator, and I'm going to type fixed like that. And this is a value that's defined in this file, which we're including here, but we're going to look into includes later on. So basically, if you just type this stuff, it should work, and don't worry about it too much at this stage. So let's run this, and it will look pretty much the same as before, really. You'll notice we've got a 2 on the end here, and we'll talk about that in a minute. But the thing here that I want to show you is you can also have this as scientific, like that. And if you run this now, then we get this in scientific notation. So this actually means 7.64 times 10 to the power of 1 in this case. Yeah, that's right, isn't it? So we've got 7.6 times 10, that would be 76. So 7.64, and this E stands for exponential, and it actually means 10 to the power of 1 here. So sometimes it will display it like this just anyway, if you've got a really long number, but I'm going to change this to fixed so that we always get the numbers written out. Now, yeah, let's run that again. So we saw that we had a 2 here, and the reason for that is you can only store a certain amount of information in a float, or in any variable for that matter. Float allocates a fixed size of memory, and if you want to see what that is, you could do what we did, I think, in the last tutorial. You could type size of float like that, or you could also use size of on your variable. So we're typing size of and then round brackets immediately after it, and in that we're putting float, or we could put f value in there, it would also work. And if you run that, you will see that a float on this compiler, at least on this system, it takes up 4 bytes. So there's only going to be a certain amount of information you can store in 4 bytes. Of course, there's a limit to it. And with floats, usually you reckon on getting something like maybe 5 or so. I think it's about 5. How many have we got here? 1, 2, 3, 4, 5, 6, 7. Yeah, something like 5 or 7 significant digits. I think we've got 7 here basically. But after that, you're just going to have garbage being output. So you can only store like the number of actual digits that matter in here. So starting from the beginning, we've got 7, 6, and then 4, and so on. And then a bunch of zeros, because it's exactly 76.4. After that, you can't rely on your float for storing numbers. You can only rely on it to store these, 5, 6, 7 digits or so. I think it's normally 7. So if you want more precision than a float, you're going to have to use a different kind of variable. And in fact, let's just output even more digits here, because you might wonder why is it actually stopped at the 2 here, where the 2 was garbage anyway, but why didn't it go on and output loads of garbage after that? Why have we only got this number of digits? And the reason for that is cout actually has a number of digits that it will output by default, a number of significant digits. And again, I think that's 7 or 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Well, we've got 8 digits, 8 significant digits here. And this could, I presume, vary on different platforms, different compilers. You don't have to carry this information around in your head. And as you can tell, I really don't, although I've done C++ for many, many years. But we can alter the number of digits that we can output with cout by using set precision. So I'm going to put another like chevron here, as I like to call it. And I'm going to type set precision, and in round brackets, after that, let's type 20 so that we get 20 significant digits being output. And again, to use set precision and to use fixed, you've got to include this IO manip here. So you've got to type this stuff near the top of your program. Let's run that and see how it looks. This is even worse. So now, yeah, we've got 7. 1, 2, 3, 4, 5, 6, 7. We've got 7 digits that are good. So float has correctly stored 7 digits, but after that it's just garbage, and we're telling cout to output a total of 20 digits here, but most of them are just rubbish. So let's try that with a different type. If you want more precision in your program, you can use double, which should store something in the region of something like 15 significant digits, approximately, something like that. Let's try double. D value equals 76.4. Let's try that again, actually, same value, and we'll output cout, and let's just copy this because it's easier than typing it again. Paste it in here, and I'm taking care to keep the indentation correct. It's very important. And let's output here D value and see how that looks. So I'll run this program, and you can see here that the double it gets much many more digits correct. Like, so we've got a load of zeros here which should be there, and then after a certain point it's garbage, just as float was. So we can make this a bit more complicated. Let's try typing, 1, 2, 3.4, 5, 6, 7, 8, 9, and let's try that same value with a float. So I'll run this, and we'll see that with float we've got 1, 2, 3, 4, 5, 6, 7, 8, and then it loses the plot. But double is doing a lot better here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a load of zeros. So we could put more decimal places or more digits before the decimal point and double. If you really want a mega precise number here, and you have to bear in mind that most of the time you really don't need to use that many significant digits, not even in sort of scientific work. People tend to go overboard with using significant digits, with using numbers after the decimal point. You normally don't need that many for most purposes, but if you're working with money or something and you're doing lots of complicated transactions, then you certainly do want as many decimal places as possible, I suppose. Whether double will be enough for financial software, I'm not really sure. But if you want even more precision, you can use long double, and let's call this L value equals, and let's have something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I'm not sure how long it'll do with that, but how it will do with that. But let's see. Let's copy this again, and now let's try L value, and let's run this. So we've done pretty well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. And after that, we've got some garbage instead of what we should have, which is zeros. So L value is a long double value. It does pretty well with storing lots of significant digits. And again, if you're interested, let's just change this here to say size of float. This is a really good thing to do. Just type this out yourself, get the size of these values. Let's say size of long double, and I'll type in here. We could just type L value. You can use either the variable or the actual type. Let's try that and see how many bytes we were allocated for a long double. So a long double is using 16 bytes in the computer's memory just to represent one number. So that's a lot of bytes just for one number. So the take-home message from this tutorial is just that you've got float, which is fine if you don't need too much precision, double, which is very commonly used, and long double, which you don't see very often for sort of mega precision. So that's all you really need to remember. And it's handy also to remember this, that you can do set precision and fixed. If you need to change the way Cout is outputting a number, and of course there's other stuff you can do to format numbers, but we won't go into it here. There's no signed or unsigned double, at least not with this compiler, and I don't think with any compiler as far as I know. So you've got these basically these three types. So that's it for this tutorial, and what I'd strongly recommend is that you just try defining some variables of these three types: float, double, long double. Also try size of on them to see how many bytes they occupy on your system. You might get different results to me because it can potentially depend on your compiler and on your kind of computer you're using. So this isn't, the number of bytes allocated to a type is not necessarily fixed in C++, although you're probably usually going to find the same results as me here, like 4 for a float, 16 for a double, and I think it's 8 for a 16 for a long double, and I think it's 8 for a normal double. But try typing that out yourself. Just try using it a bit. You could add them together if you want, see how that goes, and once you've done that, it'll sort of stick in your memory a bit, so you don't have to remember everything that I've told you here, but just practice using them a little bit in a little test program. So that's it for this time, and in the next tutorial we're going to look at the remaining primitive types in C++, and don't worry, pretty soon we're going to get on to something a bit more interesting. So until next time, happy coding.